Hey class, today we're going to talk about quadratic equations, which is found in section 4-5 of your book. We're going to solve quadratic equations by factoring and graphing. Just a little bit of vocabulary. It says whenever the graph of a function f of x intersects the x-axis, then f of x equals 0. A value of x for which f of x equals 0 is a 0 of the function. So just as a reminder, whenever you see f of x, remember that's also the same thing as saying y. So it's saying whenever the graph of a function y intersects the x-axis, then y equals 0. And we know that because that's called a x-intercept. Okay, so now a new name of an x-intercept when we're talking about quadratics is zeros of the function. And you should always have, for the most part, and not really just for the most part, you should always have 2 zeros of a function, because quadratics have to, if they go up, they have to come down, or if they go down, they have to come back up through the x-axis. Okay, it's just our job to determine what those two intercepts are. Okay, so the zero product property. So it says if AB equals 0, then A equals 0 or B equals 0. So for example, if we get as our answer two factors, for example, x plus 7 and x minus 2, then either x plus 7 equals 0 or x minus 2 equals 0. That's what the zero product property states to us. So in example 1, we're asked to solve a quadratic equation by factoring. We've already done this, okay? So this is where we state our A, B, and C, and then we use the AC method to determine what our factors would be. So A equals 1, B equals -5, and C equals 6. So AC, or A times C, will give us 6, and the factors of 6 are 1 and 6 and 2 and 3. So the factors that will add up or subtract to give you -5 are -2x and -3x. So remember, we rewrite our first and our last. Don't forget this time, however, we have an equal 0 to attach to it, okay? So minus 2x minus 3x. We're going to group the first two and the last two. The greatest common factor of x squared minus 2x is x. What's left over is x minus 2. The greatest common factor of -3x and +6 is -3. And again, we're left with x minus 2. Okay? We've done this correctly because we see that we have two factors that are the same. So x minus 2 is one of the factors. And the other factor is what's left on the outside, which is x minus 3. Now, again, not forgetting that this is set equal to 0. And that means that both factors can then be set equal to 0 to be able to determine what the zeros are, or in other words, the x-intercepts of the quadratic equation are. So then we would say x minus 2 equals 0 and x minus 3 equals 0. If we add 2, we'll get x equals 2. If we add 3, we'll get x equals 3. So the solution is x equals 2 or x equals 3. So we're going to do this again with try 1. So let's determine our A, B, and C. Again, A is 1, B is -7, and C is 12. Okay, A times C would give us 12, and the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. The ones that will in some way, shape, or form give us -7, or more specifically -7x, are -3x and -4x. So we need to rewrite. So we will have x squared minus 3x minus 4x plus 12 equal to 0. We group the first two and the last two. Greatest common factor of x squared minus 3 is x. What's left over is x minus 3. Greatest common factor of -4x plus 12 is -4. And again, we're left with x minus 3. All right, if we've done this correctly, so one of the factors is x minus 3 and the other is x minus 4. If we set each of those equal to 0, then our solutions would be x equals 3 or x equals 4. All right, let's do this again with the second try. A is 1, B is -18. No. I actually made a mistake. What did we notice, guys? What's wrong with this one? The issue is, if you don't notice, which I didn't pay attention to going too fast, is that this isn't in standard form. So it needs to be rewritten in standard form first. So I need to subtract 3x on both sides. And I'm left with, if I put it in order, I would get x squared minus 3x minus 18 then equal to 0. That's the only way that we could then find the solution by hand of this quadratic equation, is that it has to be set equal to 0. Our standard form has to be set equal to 0. So again, A, B, and C. A is 1, B is negative 3, and C is negative 18. So A times C would give us negative 18. So that's 1 and 18, 2 and 9, 3 and 6. Okay, the factors that would give us negative 3 are positive 3x and negative 6x. So if I rewrite that, I would get x squared plus 3x minus 6x minus 18 equal to 0. Graph the first two, the next two. The greatest common factor of the first set of parentheses is x. What's left over is x plus 3. Greatest common factor of negative 6x minus 18 is negative 6. And again, I'm still left with x plus 3. My two parentheses are the same, so I've done it correctly. So I have x plus 3 and x minus 6 set equal to 0. And when I'm done, my two zeros, or my two solutions, would be x equals negative 3 or x equals 6. In example 3, we are now solving quadratic equations by graphing. So this is where we would type into our calculator 2x squared plus 7x, but we wouldn't necessarily type in this 15, okay? The deal is once again, this is not in standard form. So in order to get this into standard form, we would need to subtract 15. And we're left with 2x squared plus 7x minus 15 is equal to 0. Okay? Then in our calculator, we would go to the y equals. We would then type in that equation, and we would see our graph. Okay? Then to be able to determine what the graph is, we would need to go to the 0 option in the calc feature. Okay? And there should be like a guess feature, so you'll do left bound, right bound, and then guess, and then it'll give you your x-intercepts, and you would have to do that for both graphs. So just as a sketch, it should go through negative 5, so 1, 2, 3, 4, 5, and then positive 1.5, so right in here, and then, so it should go something like that. Okay, so again, our 0, or my zeros, should have been right here. Okay, and again, I would have gone to, after I typed this in, I would have gone to calc, I would have gone down to the 0 option, and then it would have said left bound. So for example, I would have gone to the left side of this one, and then gone to the right side. So left side, enter, right side, enter, and then guess. And enter, and then it would have told me that x equals 5, y equals 0. So that would tell me that x equals 5 there. I would then do the same thing again. I would say calc 0, left bound, right bound, enter, and it would tell me x equals 1.5 and y equals 0. If you have any questions about trying to do this in a calculator, just let me know and I can help you in class. I won't exactly explain how to get this answer again in your calculator. However, I will just give you the answer. All right, and here your answer should be x equals 6 or x equals negative 4. All right, in example 4, we have a pretty lengthy word problem, so let's try and figure it out. It says, from the time Mark Twain wrote the celebrated jumping frog of Calaveras County in 1865, frog jumping competitions, I should have said, have been growing in popularity. The graph shows a function modeling the height of the frog's jump where x is the distance in feet from the jump start. So let's look at it. So again, we have a graph, and it says y equals negative 0.029x squared plus 0.59x. That actually happens to be the equation of that frog jumping. All right, so let's go ahead and look at the questions that are associated with this problem so that we can understand just a little bit more about what's going on and what this equation actually means for us. So again, it says how far did the frog jump. So if we're looking, the frog is already on the graph, right? Showing us that the frog is jumping. So the red line that we see here, or this quadratic function that we see, is the frog jumping. So to figure out how far the frog jumped would actually be the x values, right? It'd be the x-axis, or determining what's on the x-axis. And so to determine how far the frog jumped, if it started at 0, right, and it lands over here, then the distance between would be how far the frog jumped. Okay, so how do we determine that? Well, we determine that by typing into our calculator. Okay, we would type that equation, negative 0.029 x squared plus 0.59x, into our calculator. And again, we would have to find the zero. So remember, we would go to calc, then 0. And in particular, we want to know what this x value is at the end. We want to know the x value at the end. And once we find that x value, it will tell us that x equals 20.34. And specifically, it should be 20.34 feet. So the frog jumped 20.34 feet. Okay, let's look at the next question. Okay, so here's our graph. And to determine how high the frog jumped, that would be the height, right? The height of this graph. And so the height of our graph is right about here. So the highest the frog could have jumped would have been, and again, which axis does that kind of relate with? It should be the y-axis. And so in other words, we want to know the y value of this highest point. And remember, the highest point would be named the vertex. So we want to know the y value of our vertex, the y value of the vertex. And so again, we already know how to do the vertex, right? We would, well, actually you can do this one of two ways. You can actually go into your calculator and do maximum, right? So we go to calc, and then we go to maximum, and then that's left bound, right bound, enter, and it would give you your vertex. And so we would just choose the y value, or if you think about it theoretically, the midpoint of the 20.34 jump is 10.17. So if we know that the x value here, if we know that the x value, and I know it's getting really messy, but if we know that the x value is 10.17, then we can substitute 10.17 into the equation. And what we would get as our y value is about 3 feet. So the highest the frog jumped was 3 feet. And that's pretty amazing when you think about a tiny little frog, first of all, jumping 20 feet in one direction, but then on top of that, jumping as high as 3 feet in the air. Okay, let's go ahead and answer our very last question. So the first question says, how far did the frog jump? So if we thought about that in the literal sense, let's go back. The second question says, I'm sorry, let me go ahead and write this on here. It's 20.34 feet was the answer to the first question. The next one says, how high did the frog jump? So let's go back to our graph and think about that. How high did the frog jump? So again, how high did the frog jump? It jumped about 3 feet high. Okay, so it says, what is a reasonable domain and range for such a frog jumping competition? And when you talk about a graph, we could talk about the domain and range as being like the window that we use for our graph, or the window that we use for our calculator. So domain would determine how far left and right our graph stretches, right? So our domain, how far left, how far right does it go? So a reasonable domain for the frog jumping, so domain, notice the least value that we used was 0. And the highest that the frog jumped was, or the farthest that the frog jumped was 20 feet. So we can just go a little bit further so that we could be sure to see the entire graph. So we could say 0 is less than or equal to x is less than or equal to 30. Okay, and that's pretty reasonable because, again, it stopped at 20 feet, and we can just go a little bit over just to be sure that we see as much as we can. Okay, and then the range, remember the frog only jumped as high as 3 feet. So again, we only want to see a little bit more past that. And the lowest, obviously, the frog can jump is the ground, which is 0. So our range would be 0 is less than or equal to y is less than or equal to 5. And again, we're just going a little bit above the 3 feet that was given. And guys, that's it. Okay. So again, if you need any tutoring, please be sure to come in and see me so I can answer your questions more fully, especially with the calculator functions, like how to type them in or whatever. Just let me know.